So y'all have your little papers. We're gonna mix them up and make little samples or whatever of all the different incomes. Did you guys do it that way, or did you do it on the virtual way?
I just did it on the virtual way.
Oh, guess I'm old school. Did you cut up, or did you do the virtual?
I did virtual, but I haven't actually just done the math or whatever for it. So that's about it, though. Because I wasn't sure, because it was talking about how to do it with your group, and so I was like, well, we'll all get different numbers.
I know, that's what I was thinking. I'm like, I'm just going to go ahead and do it, and if I had to do more than once, it's more practice for me, so.
Yeah.
So should we do the same numbers? Or
we don't have to. I thought that'd make it easier if we were all trying to do it.
Do it together. Yeah, I think that would make it easier.
Okay.
So, you have some numbers down already, Victoria?
I just did the random integer thing, and it pulled up some numbers, so we could use those if you want.
Okay, yeah.
So, it's 24, 21, 4, 14, and 16.
Say that again. I'll have to manually look them up. Here, hold on.
I've got to switch between
Do it again. 24.
21.
Okay.
4.
Okay.
14.
And
16.
16? Okay.
Mm-hmm. So I got to get into the thing too.
So my question is, for number 7, it says randomly select 5 of the 30 and compute the mean. So do we compute the mean of the money? That's what we're doing, right?
The incomes? Yeah, that's how I understood that.
Okay. Okay. Just wanted to make sure.
Okay, I'm still picking out those numbers.
It's okay, I am too.
Okay. There's 16. Get out my calculator. So we have 52,100, 52,900, 47,800, 48,500, and 44,300. That's what I have.
Yeah, looks right on mine.
Okay.
Oh, there's Elena. Hi, Elena.
Hi, sorry.
All right. We just barely started, so.
Okay.
So it's all good.
Do you want those numbers?
So what we're doing right now, Elena, is we're just getting the 5 random numbers for number 7.
Okay.
And we thought that we would just do it together as a group instead of having 4 separate groups of numbers.
Okay.
So we got, if you want to write this down just so you can get the numbers. So we got 24.
Okay.
We got 24, 21, 4, 14, 16.
Okay.
Perfect. And then you just get with those numbers, you'll get the mean of the income from that chart on the preparation assignment.
The only observation I made when you go down to letter D of this assignment, it's going to ask us if we notice a pattern or anything with the 3 other individuals in our group. So that's the only thing.
Mm. Well, you guys said that you did yours, right?
Right. So we could
So
use
we
those.
could compare them. Okay.
Okay.
It's hard to be like not my way.
So what did you guys get for the mean?
49,120.
Okay, that's what I got.
Is that what you got?
Yeah. Alrighty.
So
Okay.
I was just gonna say on B we can't really. At least I'm doing it virtually, so I can't really make a mark on the graph.
Yeah,
But
yeah, I don't know how to do that.
I just went underneath. I just did the space underneath and tabbed over to about where it would be and put an X
Okay.
just underneath the graph. I mean, I guess it's not like it's being turned in, but
Okay, I see what you mean.
I made a mark with pencil.
way to go.
Hey, did you guys hear that BYU Idaho got a new president today?
No, really.
Really?
Or, well, I don't know if they got the new president, but
Not
President
President
Clark
Clark
got released.
released, or is it a release? I think.
Uh-huh. I guess that's what it said, so.
Oh wow.
Oh,
And
Is it anyone we know?
the guy, I think his name is Clark G. Gilbert, right? Is that right, Elena? Because you're up at.
Yeah.
you're
Yeah,
up
it's right. It's Clark Gilbert.
So, did they actually call him today, or is that in the future?
Did you go to devotional?
No, I'm in Utah.
Oh, I thought you were on campus. Yeah, so what happened was Nelson came and he spoke, and it was a quick talk. It was kind of weird. We're like, it should have been longer. And then he's like, now we want to announce, that we're going to call a new president. But Clark will still be until April. So.
Oh. Okay.
Oh, okay. Cool.
But they did technically call him. So.
Oh, cool.
Yeah. It was cool. It was a really cool devotional.
Cool.
I was trying to get it online and I couldn't get it through.
Oh, that's stinks.
So it's like, oh well. I guess actually last Saturday, Elder Nelson was around here, but for some reason they didn't invite our steak, but they invited the next steak over. So I got the message from them, but I hadn't checked my email or whatever all day, and so I didn't get it till that evening, after it was already done. And I was like, it was just like 20 minutes away.
Interesting. Okay, so 7C. Are we ready? Does your sample mean
Yeah.
appear to be unusual? Explain why you think it is or it is not unusual. I put no, because the sample population is 30, so that's kind of the 30 and above is considered, for this class purpose, is large, and so if it's from a larger draw or larger population, sample population, then you're more likely to have more accuracy. Is that right? Am I wrong in that? What did everyone else think? Because when I draw on the line for that income amount, it's still on the bell curve, but it's not symmetrical. It's kind of to the right. So is that considered unusual, or is that usual?
Um,
Well, I feel like the reason you know something is unusual is because of the z-score usually. And
Right.
because we don't really have standard deviation or anything to tell us that, I'm not sure how to. I would probably just go with like what you're saying.
Well, I was hoping you would also have some input there, but based on what we learned in this last section or whatever.
Yeah. Looking for my little notes. Well, our sample mean is there's only 5 numbers though, right? So
That's true. It's not really 30, is it? Because we're drawing from 5. That's true. So wouldn't that be normal? Unusual, or usual, sorry. Usual. Be unusual.
Yeah. Yeah, because it says with the central limit theorem that if the parent population is almost normal, 5 is enough. But
Right.
I'm not sure if this counts as that. Or if that has nothing to do with this. You were saying it was going to be usual, right?
Yeah, because I was originally looking at the 30 salaries. That's where it was drawn from, but
Yeah, well, I think it'd still be usual.
and why? So why would it be usual?
Because the bell curve is still normal, and so your distribution is still normal,
Okay.
and then I think Mindy explained it better than I am right now.
well, I just remember where it said, and if you draw from a larger N or a larger sample population, then your accuracy is better, and the standard deviation decreases. So when you have a larger group to draw from, so my thought was, well, okay, we started with 30 salaries, so therefore it's a larger sample population. But then she mentioned, well, we only did it from 5 really out of those 30. So does that mean that 30 is the parent population, and then 5 is, since that's a large one, and that's a even distribution, then therefore the 5 is also follows the same thing. I don't know.
Yeah, so I think the population is the 30,
Okay.
and I think that's the bell curve that we see
Right.
here, and it's normal, and so your what do you call it? The distribution's going to be normal because of that, and so our value is usual because it's within that range, I guess, and it would be the right amount, the right. I cannot think of words.
That's okay. But yeah, I think that makes sense. So.
Okay, as long as you're understanding. Or that you understand it for yourself.
Alright. Well, 7D says compare your mean from question 8A. We haven't done anything. To the means obtained by at least 3 other individuals. What do you notice? Does that want to say 7A, do you think?
Mine says 7A on mine.
Really?
Mm-hmm.
Okay. Well,
Compare your mean from 7A.
I wonder why mine says 8A. That's goofy. Okay.
Yeah.
Well, compare your mean from question 7A to the means obtained by at least 3 other individuals. What do you notice? In practice, you only get to see the means from the same.
So
Okay, well, when I did it on my own, I got 44,340. Anybody else did it on their own?
No, I can do my own numbers right now. I'll do it real quick. 7.
I can probably do one real quick too. Let me get.
So for this one, I got 46,820.
What'd you say? 46,820.
820.
Okay.
Okay. I just did another one too.
What did you get, Victoria?
I just got 43,220.
Okay. Then did you get one, Elena?
Yeah, I got 46,280.
Oh, cool. Cool. All right. So what do you notice in practice?
I feel like our stuff kind of fell into the same categories, I guess you'd say, like the same kind of distribution.
Mm-hmm. Yeah. Yeah, it's true. Oh yeah, that's true. Huh. Interesting. Cool. Okay. Yeah. Well, awesome.
So,
Excuse me.
is that all we want to say then? And then just go on to 8?
Yeah, I think so.
Okay. I did do 8. I think I did the last one right though.
Okay. So 8A. Alright. It says the graduate management admission test, the GMAT, is used as an admission criterion in many Masters of Business Administration MBA programs. The scores on the GMAT are normally distributed with a mean of 529, a standard deviation of 113. Consider a random simple sample, or n equals 10, students taking the GMAT. So what is the shape of this distribution of the sample means for all such samples? Would it be normally distributed?
Yeah, because the parent is normal.
The parent mean of 529?
That it's normally distributed in general, so it's just doesn't really matter any of the other numbers. Whatever sample size you get
Oh,
is going to be normal.
that's right. That's the key right there. Normally distributed with a mean of 529.
Yeah.
Okay. So we can say bell shape or normal.
Mhm.
It says, how do you know that the distribution of the sample mean has this shape? Well, just because what you just said.
Yeah. So that's what I just said was just the central limit theorem. So and that's just that if the parent's normal, then your sample's normal.
Okay. And then see what is the mean of the sampling distribution of sample mean scores for all such samples. 529.
Mhm.
Yep, that's what I put too.
Yeah, because your mean's always going to be the same. At least that's kind of how I understood it. Was your mean will always be the same. Because if you have a big enough sample size, it'll be pretty close to the same between your population and your sample.
Right.
And then what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? Just 10, right?
I got 35.734.
Oh, just joking. I was wrong.
Yeah, that's
So you take that new formula that we learned. It's not sigma, is it? I know the O over the root of the sample of n. So 113 over the root of 10.
Oh yeah, there.
What is that formula called again? The standard deviation of sample means, I guess.
Yeah, the standard deviation of the sample mean. I feel like they should call these something else to make them a little bit easier to say. I don't know.
Okay.
Whenever I was reading it, it was like I was getting distracted by so many words.
I know.
Just
There's so much terminology. I've been making myself a little chart to make it more concise. So anytime I have a moment, I can just quickly, go over something in my head while I'm multitasking.
That's a good idea.
I think maybe we should go over the idea of the law of large numbers comparison with CLT or what's it called? The central limit theorem. So we to me, I still want to make sure I understand that. How about you?
I think I got it, but it doesn't. It does not hurt to go over it again.
Yeah, it might be on our quiz. So.
Yeah, I think it probably is. I think it was on the. I started to do the homework or whatever, and it was on there.
Did you?
So, when I was writing it down, I just had the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. So, the shape, I think central limit theorems, there's just the shape of it, right? The distribution and how it kind of looks. With the Anyway. Sorry guys, I feel like I'm talking a lot.
No, that's fine. That's where I'm kind of like foggy. I'm like, okay, what's like the one way you can really describe it? If you had to describe it to your roommate or to someone else or your spouse, or this is what I learned in class. This is how do you describe what the central limit theorem is to someone else that's not taking this class?
Yeah.
So yeah, I put sample size is large, then the sample mean will be normal. That's what central limit theorem guarantees, I guess. Or if you have a large sample, then your sample mean will be normal. And the law of large numbers, the sample mean will be close to the population mean if there's a larger sample. But I need a better definition than that. I think that's kind of not a very good one.
Law of large numbers. I kind of thought of it as like if the sample mean is big enough, then the sample mean and the population mean are pretty much the same.
Okay.
So I don't know if that helps at all, but that's kind of just how I thought of it, is that they're pretty much the same if the sample is large enough.
Sample, put that in pen.
Cool. Yeah, I think I get that. Well, do you think you guys are ready for the quiz?
We can try. Between all of us brain trucks here, right? Alright, let me get to it.
Start it then? Or should we wait?
Lena, are you missing girls' night again?
No, that's Thursday night.
Oh, that's Thursday night. Oh, okay.
Elaine, where do you live on campus? Like, near campus?
Do you know North Point?
Yeah.
Right across from the track? Yeah.
Cool. Awesome.
Yeah.
Oh,
Yeah, I like it.
That's cool.
You have friends there?
Yeah. One of my cousins lives there also.
Okay, that's cool.
Yeah.
If I ever make it to Idaho, will you show me around? I've never been there before.
Yeah, of course.
Okay.
If you're around Boise, that's where I'll be.
What's that?
If you're around Boise, that's where I am.
Oh, okay. Is that the capital?
Yeah.
Yeah.
There's not much, though.
Oh, okay. It's probably a lot more affordable to live there than California, that's for sure.
Yeah, I think that's why we get a lot of people that kind of from California tend to retire here.
Yeah.
Cool. Alrighty.
Trying
Well,
to get both of them up at the same time, but it's not working very well. Okay.
Does everyone, or so you said you're looking it up, Mindy? Or you're
No, I'm trying to
pull up
get
the quiz?
the both screens up at the same time so I can not have to flip back and
Oh,
forth.
God.
I'm trying to minimize
Gotcha.
them. There we go. I think I got it. Just have a smaller screen. All right. Let's see. All right. Are we on 3 together then?
Yep.
Yeah.
Alrighty. So when taking samples of n, when n equals 5, what was the shape of the distribution of means, histogram, when the parent population is right skewed?
Say it's also skewed right.
Okay. That makes sense.
Just because
Yeah.
it's
Maybe the same, like you said.
yeah, it's not a big enough sample size to change it.
Okay. Okay, and then it says, number 4, when taking samples of n equals 100, what was the shape of the distribution of means, histogram, when the parent population is right skewed? Wouldn't that be normal
Is this
Yeah.
referring to that applet that we
for that?
practiced with?
I
What?
think
That applet that we were supposed to play around with, is that referring to that?
I think so.
I think that's just what we kind of use to like introduce it a little bit more.
Okay.
I don't think we have to use it.
All right.
Yeah. But so number 4, did you get normal for it?
I'd put normal, yeah,
Okay, that's what I was
because
thinking.
your sample size has to be greater than or equal to 30, I believe.
Right.
Somewhere. Yeah. Yeah, if it's heavily skewed and has to equal 30 or greater than 30.
So you're saying it for number 4, it's normal, right?
Yeah.
Mhm.
And then number 5, when taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? Normal, right?
Normal.
Yeah, normal.
Did you already take this quiz? Or you did? Oh, okay.
Mm,
Okay. And then when would the distribution of means be normally distributed? Distributed, I always say.
It's okay.
Um, Data are drawn from a population that's normally distributed and the sample size is small. Um,
So we want the sample sizes to be large, right?
I
Yeah.
think so, yeah.
That would go with B, or the second one. And let's see, is there another one? That's right.
So
That's all. There isn't any other one that's correct. It's just the middle one.
the ones on mine, I have normally just, if the parent is normally distributed, it doesn't matter what sample size it is, so I have it for both the small and large,
Oh, okay.
and then the right skewed if the sample size is large.
Okay.
Do we have
That's what I
different
have.
choices? Is what you're saying for the quiz?
That's what I was asking if we did.
Okay, well, let's compare then. My first one is data are drawn from populations normally distributed and the sample size is small. Do you guys have that one?
Mm-hmm.
Okay. Data are drawn from populations normally distributed and the sample size is large.
Yeah.
And data are drawn from a
And those-
population that's right skewed and the sample size is small.
I have that, but don't check that.
Yeah. Okay. So I think it's A and B, or first and second.
Yeah,
Not
it's
sure.
the first and second one, and then the right skewed will be normally or approximately normal if the sample size is large.
So all of them are correct?
All except for the sample size, the right skewed, and the sample size is small.
Okay, so the first and second one.
So first, second, and fourth.
Because when the sample size is large, it puts enough data in there that it kind of gets rid of that skewed distribution.
Oh, I didn't realize there was a fourth option. I'm so minimized. I didn't
Oh.
see it. Like, what are you guys talking about? Oh, okay, there it is. Sorry.
We got to keep you on the right path there.
Ah, okay.
So 7. Which of the following gives the best explanation of the central limit theorem?
There we go. Okay. We could look at our notes, right? Didn't say can't.
I think you can, because I know you can with the homework quiz, so I wouldn't see why you wouldn't with this one.
Right.
I think, because there's a question like this one on the homework too, but it's for the other one, and it's the sample size is large and the sample mean is close to the population, but that's the law of large numbers.
So that wouldn't be.
And so I think the central limit theorem is if the sample size is large, the shape of the sampling distribution
Right, because you're
of
talking
the sample
about how.
mean
Yeah.
would be approximately normal.
I agree with that.
Okay.
How many questions are in there? 11 questions. Okay.
Okay. So we got for number 7, if the sample size is large, the shape of the sampling distribution of the sample mean x will be approximately normal.
Yeah.
Yeah, that's what
Okay.
I put.
Mm-hmm.
And then 8. So this one we just use that equation, right?
Right, I was just going to say that. It's
Yeah.
a little bit of tinkering.
Well, for 8 is just the same mean, isn't it? Because your sample is going to be, your sample's big enough, you should be able to use the same mean. Is that right?
Well, yeah, it's over 30, right? Because that would be
Yeah.
central limit theorem going along with that.
Yeah.
Oh, okay. I understand what you guys are saying.
Okay.
So it would be just 10.
We all agree with that? We're all agreeable to that?
You just said it was 10?
Yeah.
Okay. Sorry, I heard N for a second and I was like, no, that's the same. No, okay. So 9 is the one.
Where we
So,
do
right?
a little bit of work here.
So for 9, did you get 1.000?
I'm not there yet. You're quick.
Sorry.
6. 6.
Do we have to put the 3 zeros? Do you know?
I just do that just to be safe.
It says 3 decimal places, doesn't it?
Yeah.
Yeah,
But
that makes
I
sense.
just do that just to be safe. But
Yeah.
for number 8, I don't think we need to, just because it doesn't say.
Yeah. Okay.
So we're putting just 1?
1.000.
Okay.
Alright, and then number 10, regardless of the distribution of the population, if the sample size is large and is greater than 30, what would the shape or distribution of the of the sample mean? Normal?
Yeah.
And number 11, what theorem would justify your response to question 10?
So that's
CLT.
the essential. Yeah. That's easier to say. Huh?
That's how I have it in my notes. Central limit theorem, CLT.
Yeah, central
I
limit
don't have
theorem.
time to write the whole 3 words. Just kidding.
I know what I was writing. I started writing DSM for distribution of sample
You
means.
do the same thing. It's how you take notes, right?
Yeah.
It sounds like almost BLT. I want a BLT. No, it's a CLT.
It's like bacon. No, that's not it.
How's that work? Okay.
But,
Cheese, lettuce. I don't know what T would be. What would be T?
Tomato.
Cheese, lettuce,
Tomato?
tomato. Thank you, honey. Tomato. That's what I said. Central limit theorem. Cheese, lettuce, tomato.
Well, we good to turn it in?
I just submitted it. So
Okay.
Look at you.
but if it helps, I got 100%. So
You got 100%? Okay.
yeah, you guys should be good.
All right.
Well,
Hopefully I did all right. Yay.
well, awesome.
High five in the sky.
Oh, I have to like see the screen to do it.
Now you all want to have a BLT, huh? Bacon, lettuce, tomato sandwich.
A little bit.
Central limit theorem. Cheese, lettuce, tomato.
If I don't like tomatoes. but,
Yeah,
but that's okay.
I don't like them. Selectively, I like them. Maybe on a taco or in salsa. That's about it.
Well, alrighty. Well, I'll see you guys on Thursday then.
Okay, I have a question. Do anyone know what the project we're going to have to do